Hi, this is Miss Logan. Today I'm going to be talking about right-hand rules. Alright, so there's 3 right-hand rules we're going to talk about. So for this lesson, make sure that you are actually doing the right-hand rules with me. So the first right-hand rule is for a straight wire. So through our right-hand rules, we're trying to figure out what is the direction of the current and the direction of the magnetic field. So take your right hand, curl it around, like in the picture. Your thumb gives you the direction of the current, okay? And the negative is always on top, and your fingers show the direction of the magnetic field. So this is for a straight wire. Thumb up is the direction of the current, fingers curled around is the direction of the magnetic field. All right, so our next right-hand rule will deal with solenoids. So this is what we worked in our lab. It's a coil of wires that produces a magnetic field when a current runs through it. So let's think back to the right-hand rule number 1. If our thumb was facing out of the page, you can do this with me, then my current would be going around. So our second right-hand rule is really similar to number 1. So it's the same kind of principle as right-hand rule number 1, but it shows different things. My fingers curl in the direction of the current. So remember, this is for our solenoids. We have a wire wrapped around something else. And our thumb points toward the North Pole. So take your right hand, curl it like is in the pictures. Your thumb is going towards the North Pole. Your fingers are indicating the direction of the current or the wires. All right, our last one, which is the one we'll work most in class, is our right-hand rule number 3. So this is moving charge. So this one is a little bit unique because we have 3 players rather than the 2 that we previously had. We have an electron or proton with some type of velocity. It's in a magnetic field, and we have some type of force. Don't worry about the really deflection, just worry about the force, okay? This one rule is that everything has to be perpendicular or right angles with each other. So for right-hand rule number 3, for protons, we're using our right hand, and for electrons, we are moving our left hand, okay? So just keep that in mind for protons, right hand, left hand, electrons. Now I'm going to explain what this means. Okay, so our last right-hand rule, and we're going to practice all these right-hand rules in class, so if you're wondering why I'm not doing examples, that's because we're going to spend a lot of time working on them. So right-hand rule number 3, our thumb is the direction of the current, or it's the velocity, okay? It could be either one, and you'll see how they are both similar very soon. The fingers are the direction of the magnetic field. So something to note for this is that it's denoted by X or a dot. Dot is towards us, X is away. And then our palm is our direction force. So remember, your palm should always be face forward. If you actually are turning your hand around the other way, that means you need to use your actual other hand. Okay, so we'll work with that during class on how to do these in different situations. Okay, so our equations for the right-hand rule number 3, we have 2 different ones. So we have the force is equal to the magnetic field strength times the current times the length of the wire. But if I have a charged particle, all we're doing is changing 2 of these right here, okay? So we need the velocity of the particle and the charge in coulombs. We'll play with these a little bit in class. So we will be actually working with these equations in class and our right-hand rule. So make sure you have this information so we can apply it in class on Monday.